This tracing illustrates the characteristics of the SecureSense algorithm during a real episode of ventricular arrhythmia. This patient, implanted with a single lead ICD, was hospitalized after an episode of syncope during which he received an electrical shock. Initially, we see a slow and irregular basal rhythm consistent with atrial fibrillation and a slow ventricular response. Then, a PVC will trigger an episode of fast ventricular arrhythmia. Initially, we see these unclassified cycles because there is a discordance between the current interval and the mean value of the 4 previous intervals. After the detection of the second fast cycle on the bipolar channel, there is an activation of the noise counter on the discrimination channel after 350 milliseconds of warm-up without possibility of sensing. That explains why this cycle is not sensed on the discrimination channel. In this episode of arrhythmia, there is correct sensing at the level of the bipolar channel and at the level of the discrimination channel, with fast cycles classified VS2. The noise counter will be incremented by 1 after each fast cycle detected in the bipolar channel. But this noise counter will be reset to 0 after 2 fast cycles detected on the discrimination channel, even if they are not consecutive. So, since there is a concordance between the two channels and a correct sensing at the level of the discrimination channel, the noise counter is reset to 0 all along the episode. Here, the VF counter is filled, so the noise counter is now analyzed. It has been systematically reset to 0, so it is less than 10, and therefore the device considers that this is a real arrhythmia and the therapies are delivered. It is a burst during charging. You can see here the charge of the capacitor. This burst is non-efficient. There is still a ventricular arrhythmia. At the end of the charge, the shock is delivered on the second fast cycle. You can see that this shock is efficient. And you can see here oversensing at the level of the discrimination channel after the shock has been delivered. After 1, 2, 3 cycles classified VP, there is a diagnosis of return to sinus rhythm. The SecureSense algorithm was initially designed to enable an early diagnosis of lead dysfunction. The functional principles of this algorithm are based on the discordance and on the comparison between the bipolar sensing channel and the discrimination channel. A noise counter increases when short cycles are limited to the bipolar channel and are absent on the discrimination channel. This tracing illustrates the characteristic aspects of the SecureSense algorithm function during a real ventricular arrhythmia. The noise counter is not constantly activated. When it is inactive, the VS2 markers are missing on the discrimination channel. The activation on the bipolar channel of 2 fast instantaneous cycles. This second cycle is followed by 350 milliseconds of warm-up, where sensing is not possible on the discrimination channel. That explains why we cannot find the marker VS2. The number 2 of the marker VS2 corresponds to sensed events in the second sensing channel. Whether this cycle is short or long, all signals sensed in this channel will be marked VS2. There is no VS, VF or VT marker on this channel. The algorithm suspects a true ventricular arrhythmia and does not inhibit the programmed therapy when both channels are concordant. Short cycles are detected on the bipolar channel and on the discrimination channel. During an episode of ventricular arrhythmia, the occurrence of short cycles on the discrimination channel prevents increases in the noise counter, which is reset to 0 after 2 short cycles are detected on the discrimination channel, even if they are not consecutive. The definition of a short cycle on the bipolar versus the discrimination channel is different. On the discrimination channel, it depends on the number of zones of tachycardia programmed and on their rate limits. It is going to be 30 milliseconds above the limit of the lower zone if 2 or 3 zones have been programmed. In this patient, the threshold defining a short cycle on the discrimination channel is therefore 360 milliseconds plus 30 milliseconds, 390 milliseconds. When the VF counter is filled, there is an analysis of the noise counter. During a real ventricular arrhythmia, the SecureSense counter is less than 10 and the therapies are delivered. After an electrical shock, oversensing may appear on the discrimination channel because of the poor quality of the signal. Therefore, after the delivery of an electrical shock, the SecureSense algorithm remains inactive until the next return to sinus rhythm has been diagnosed.